Neon signs flicker over midnight loading bays as forklifts slide sealed crates toward a nameless glass tower. Not a product launch, but a pause order. Not a keynote, but a quiet phone call that tells engineers to power down benches and return borrowed cards. In the server room, the fans keep spinning, but the tests stop mid. The message is simple. Stand down on those chips. Here is the promise. By the end of this briefing, you will have a practical map for what China's directive against specific NVIDIA parts means for model training, procurement, and geopolitical risk, and how to position roadmaps, budgets, and partnerships when supply turns into strategy. If that's the map you need, share this with one operator who needs it and tell me in the comments which constraint hits you hardest. Yesterday's world let software outrun hardware rules. Buy accelerators, rent extra racks, and scale by credit card, while regulators focused on content and privacy. Today's world splits into three lanes that tug against each other. There is compliance compute, where the first question is whether a part is permissible under export or import rules. There is performance compute, where teams chase memory, bandwidth, interconnect, and energy per token trained. And there is sovereign compute, when nations try to reshape supply so critical models can be trained and served on domestic hardware with domestic support. Three constraints set the physics. First, policy ceilings. When a regulator draws a box around SCAS, substitutes that look close on paper still hit hard limits in the field. Many parts built for constrained markets sit just under cap lines, lower link speeds. Trimmed I/O, stricter firmware so. The bottleneck moves from flops to fabric. In plain words, the number of chips matters less than how fast they talk. When inter-GPU bandwidth falls, the queue for gradient exchange grows and time to resolve stretches from days to weeks. Second, platform fit. Models and training code bases are tuned to specific memory maps, kernel libraries, and driver stacks. Swapping two compatible cards is not plug and play. It imposes porting work that steals calendar and introduces new failure modes. Define the loss simply. Every week spent reshading or high profiling is a week not spent improving data quality or scaling corpus size. Third, capital friction. Procurement, customs, and compliance gateways become part of the critical path if approvals slip or audits stall. Kalendarchimi, not compute time, becomes the blocker. Amplifiers multiply or dampen each constraint. Licensing carve-outs tied to specific workloads or to verified cloud tenancy can reopen doors, but only when backed by auditable controls that agencies trust. Corporate governance amplifies speed when procurement, legal, and labs share one fact sheet and one risk register. It dampens it when teams debate definitions while shelves sit empty. Financing terms amplify pivots. If vendors will repaper deals into service credits or compute hour reservations, they dampen when deliveries are non-cancelable and deposits are trapped in limbo. Public funding can help only if it buys the bottleneck packaging slots, power interconnects, inspection capacities rather than press releases. Now the decision hinges the levers that bend the curve. Decide the training architecture by interconnect first, not by peak flops. A slower mesh punishes large global batches, so shrink step sizes, tighten activation checkpoints, and favor optimizers and parameter states that compress well. Failure mode. Holding the original batch plan and spending months to regain stability. Decide your sourcing geography by enforcement risk, not brochure speed. A 10% slower part you can buy all year beats a faster ghost you cannot actually receive. Failure mode. Planning around inventory that policy can erase. Decide the mix between pre-training and retrieval. When accelerators are scarce or throttled, lean harder on retrieval augmented generation and domain adapters. So you buy quality with documents instead of brute force. Failure emoji. Chasing a bigger, dense model when the needed facts already live in your corpus. Decide the balance between on-prem and cloud. On-prem gives control when policies swing. Cloud gives elasticity when queues open. The wrong choice shows up as either idle iron or missed windows. Failure mode. Locking CAPEX into stranded sites or paying surge pricing for routine work. Decide the contract scaffolding for suppliers and customers. Negotiate take or pay with flexibility bands tied to policy and power. Index part of your pricing to capacity, costs, and verification burden. Failure mode. Fixed terms that force you to eat penalties or sell below all-in cost. Second order. Consequences arrive quickly. If certain accelerators disappear from the cart, the value of interposer capacity, HBM stacks, and high-speed copper becomes the new rent. Memory bandwidth sets the floor on training latency. If domestic clouds cannot scale on preferred parts, on-prem clusters regain status for teams with power and capital, while smaller labs pivot to parameter-efficient training, distillation, and retrieval. If procurement cycles slow, open-source baselines with strong token efficiency attract talent and customers because they do more with less. If certification gates multiply, reproducible evaluation sets and compliance dashboards become strategic assets that close deals faster than raw claps ever did. You can already trace patterns on the map. In mainland hyperscalers, teams prioritize compute that fits both letter and spirit of guidance. Then we write schedulers to prefer pipeline and sequence parallel mixes that tolerate weaker fabric. In cross-border firms with R&Ds split across jurisdictions, projects fork prototyping happens where parts are abundant with clear interfaces that allow drop-in adapters when results are ported into constrained regions. In universities and state labs, funding rotates toward energy-efficient methods. Data curation and public evaluation suites that reduce retraining cycles and ease audits. Honest limits deserve daylight. No amount of clever sharding turns a slow interconnect into an HBM miracle. You can trade memory in for math. You cannot trade bus width for free. Policy can change faster than purchase orders. A letter that opens a door in March can close it in May. Substitutability is real, but not perfect. Different kernels, different error modes, different service tools, different yield curves. And the most stubborn limit is human time. When compliance becomes a critical path, your best engineers spend their best hours documenting flows instead of improving models. Plan for that cost. Delivery now the playbook that turns headlines into moves. Start by defining what good means in metrics you control. For training, track tokens per dollar, tokens per joule, and tokens per week to a target loss on a fixed corpus. If a rule halves bandwidth, you know exactly how the slope changes. For inference, track cost per 1,000 output tokens and latency at P95 and P99, the 95th and 99th percentiles that describe the slow tail users feel. For governance, track time to rebaseline when a policy shifts. Days from rule to compliance sign-off with name owners and checklists. Make the numbers boring and visible so decisions accelerate. Choose architecture by basin and segment, not by slide. In regions with tight enforcement and limited fabric, emphasize retrieval augmented generation, knowledge distillation into smaller students. Mixture of experts with sparse activation and quantization to 8 or 4 bits where quality holds. In regions with permissive access and strong power, reserve dense clusters for periodic pre-training and cross-lingual alignment, exporting only weights and evaluations that pass review. Treat schedulers and roadmaps like traders. Batch the biggest jobs into stable windows. Run risky experiments on sandboxes that can be paused without penalty, and align maintenance with audit calendars so a visit never knocks a milestone off the rails. Route easy cases to lighter paths and escalate only when necessary. Store difficult prompts and mislabeled edge cases as gold sets that automatically exercise new builds. When a rule shifts, replay the set and publish the deltas. Co-invest in shared infrastructure that buys durable license to operate a neutral evaluation lab that publishes reproducible tests, a transparent incident process that shows fixes by date, and a modest on-prem cluster earmarked for policy. Audits so you never borrow production capacity for demonstrations. Above all, instrument observability so nobody guesses. Utilization at the pod and rack level, aero budget burned by cluster, and compliance lead times in hours, not anecdotes. If dashboards speak plain English, the business will use them. For procurement, split the stack into movable layers. Keep the policy layer system prompts, refusal reasons, retrieval filters, jurisdiction specific, and keep the modeling layer portable across vendors with ONNX or similar exports and adapter-friendly checkpoints, so you can land on alternative hardware without rewriting your soul. Keep the serving layer containerized with feature flags that enforce hardware quirks and log them. Pin contractor obligations to artifacts you control. Evaluation reports, latency tails, and compliance attestations rather than fragile part numbers that can be revoked. Tie milestone payments to capability delivered under audit, not to inventory receipts that policy can strand on the tarmac. Communication is part of execution. Explain to customers which tasks route to which stacks and why. Publish a short cannot. Will not list and keep it current. When you downgrade a cluster or shift providers, say so and show the new tails. Clarity prevents panic. Opacity invites rumors that do more damage than a spec sheet ever could. Invest in resilience you cannot buy overnight. Train operators to swap boards, retime links, and read error logs with calm precision. Build a small policy SWAT that can render a new rule into operational checklist within 48 hours. Keep a rolling library of proof. In Assange demo screens, you can show auditors that prove routing, logging, and refusal behavior. Do what your contract says. Bottom-proof precision is a moat when rules change fast. Recap the principles. Define success with tokens, jewels, and tails so stories turn into schedules. By the bottleneck bandwidth, packaging slots, and energize megawatts before you by new slogans. Separate policy from weights so rule changes don't demand retraining. Manage the tail, not the mean, because users feel the worst minute, not the average hour. Write contracts that pay you in capability, not in chaos that can vanish between meetings. Now you have a working map for a world where a regulator's paragraph can redraw a compute roadmap overnight. The constraints that set the rhythm, the amplifiers that change the clock, the hinges that bend the curve, and the playbook that turns pressure into throughputs, you can certify. If this helped follow and subscribe, then tell me in one tight line which single constraint or decision you want unpacked next so we can make the next brief even more surgical.